simplify the following. In the first case, I have a negative outside of the brackets, then inside the brackets, negative n squared bracket with a 5 on the outside. So the 5 on the outside needs to apply to anything inside the brackets, but not the negative out in front. So that negative out in front is going to stay there. Now a negative n squared is like saying negative 1 times n squared. So negative 1 to the 5th power is still negative 1. So anytime you see a negative sign with an odd exponent, like 3, 5, or 7, it's going to stay negative. If it was an even exponent, it would become positive. So I'm going to leave the negative sign there, and then I'm going to use my power of a power law here that says 2 times 5 makes 10. Then I'll simplify my negative signs. Now the 10, again, is only applying to the n now. So now it's just a matter of simplifying negative signs. Negative times negative is a positive, so my final answer is n to the 10th. In the next example, make sure you take your time. There's a lot of numbers here, so I've got 4y cubed times 3x squared, all of the 4th power, and in the denominator I have 6x to the 5th. If you see anything that can be simplified within the brackets before you start, you probably want to do that. In this case, I can do that. In my numerator, even though I have different variables, I can still start by combining my digits, 4 times 3, to get 12. And then I'll write my x to the 6th y cubed. And I couldn't simplify those or do anything differently with those, but I can write them next to each other to show that they're being multiplied. And then 6x to the 5th. And that's all going to be to the 4th power. The other thing I sort of want to do now is simplify my digits. 12 over 6, so 12 divided by 6, which is 2. And in this case I have x's that can be simplified as well. X to the 6th divided by x to the 5th, which is x to the 6th minus 5, or x to the 1. And then the y has nothing to simplify with, so it's just y cubed. Now because I took that extra time to simplify everything within the brackets, now when I apply the external exponent of 4, my work is a lot easier. Don't forget though that the 4 still has to apply to the 2, the x, and the y. So 2 to the 4th power is 16, x to the 1 times 4 is 4, and y, I'll take the 3 and multiply it by the 4 to get 12. Now if you didn't know to simplify what's in the brackets first, and you applied the exponent of 4 to every term you originally started with and then simplified, you would get the same answer I did. So the order doesn't really matter, but I saw that it could be simplified, so I tried to save myself a little bit of time. Now with part C, again, they're trying to trick you a little bit because certain things have exponents, certain ones don't. Some have other exponents applied to them and some don't. So in this case, the 2 on the outside, for example, is applying to the x and the y, but it's not applying to the 16, which is not included in the brackets. So my numerator would be 16x to the 6th, y to the 10th. And then in my denominator, everything has to have that cubed applied to it. So 2 cubed, which would make 8, and x to the 2 times 3, which is 6. Then as a final step, I'll go through and simplify. So what I have left, 16 over 8 can be divided to get 2. Then I have x to the 6th divided by x to the 6th, which is really x to the 6th minus 6, or x to the 0 power. We all know that x to the 0 power equals 1, so really that variable is just eliminated. I don't have to write it at all. Instead, I'll write my y to the 10th. And then for the last example, 5ab to the 6th all squared multiplied by 4a squared b. So let's start by applying that squared symbol to everything in the first set of brackets. So 5 squared is 25, a squared b to the 12th times 4a squared b. Now we've seen examples like this before. We're going to take the digits and multiply them together. In this case we get 100. Then we sort of collect like terms. So our a squared times a squared is a to the 2 plus 2, or 4. And then our b, I have b to the 12th times b to the 1st. Remember, with no exponent showing, it's a 1. So that's b to the 12 plus 1, or 13.